Coding Club of FIU. So this is a very new club in FIU, the only club and the first club dedicated to artificial intelligence. It's a registered student organization, right? And just to go back, it was a funny way how we started this club. Me and Ketul were interacting in an evening, just sitting and just drinking coffee, and then we were discussing about AI and future of AI, you know. And then we suddenly came up with this, that there's no club in FIU which dedicated to AI, and we don't have a club where they invite professors, industry people, which can connect to the students and give some connection. You know, you can meet them, get connected to the industry. That's how we just started this club, right? So, and let's meet our team. This is Ketul Palara. He's the president of the team.
Yeah, so good evening, everyone.
Yeah, no problem.
Okay, so good evening. I'm Ketul Polra. I'm graduate research assistant in Energy Systems Research Laboratory and pursuing information technology as my master major. And I like astrophotography. That's like, I just started it. So if anyone wants to just join, like, you know, to explore universe also, you can just hit me up. And the purpose of our group or our club is to democratize AI, you know, like, so teach different industry people from finance to e-commerce to, like, say, energy, to like harness the power of AI and get a competitive edge.
Thank you.
No problem.
And this is me, Yashas. I'm a PhD student of Computer Science Department, and I'm a graduate research assistant in the Fines Research Center of Excellence. I'm working under Professor Iyengar. You can just send an email if you have any questions. And that is Kashif. He's the treasurer of the club, and he's pursuing his master's in computer science. Thank you. And this is Tulsi. She's our secretary. She's not here today. She's an undergraduate student in, majoring in Internet of Things. And that is Manasa. Do you want to speak? Okay. She's pursuing her master's in computer science. She's a social media coordinator, who will be taking care of all our social media instruction. And this is Precious. He's our RSO representative. He represents our group with the Registered Student Organization Council of FIU. And Professor Iyengar is our faculty advisor of the club. He's the distinguished university professor and the founding director of the Discovery Lab. Professor Iyengar has supervised over 65 PhD students and over 1,000 masters and undergraduate students. Professor has published over 650 research articles in huge journals such as IEEE Transactions, ACM Communications, and so on. And he has authored and co-authored, edited on 22 books and 9 patents. So if you have any questions, you can email iyengar@cis.fiu.edu. So Professor Iyengar, you want to speak a few words on AI and its future?
Well, I'm honored to be here, and the most important thing is this is a very interesting club because, as Yashas was talking about, I was a director for almost 9 years, and at the Knight Foundation School of Computing and Information Science, and I had a very outstanding colleague, Steve Lewis. He's going to be introduced very soon. And of all the things what you have seen is really the marvelous development, tech stations and other things, and he is the person who did contribute a lot. Okay, so welcome to this club. I think we will grow this club, and we'll get a lot of nice people from industries and all of those things. But this is a good starting point, and we have an excellent speaker today, and Steve is going to introduce. Thank you. Welcome.
Thank you so much. If you'd like to be a part of the club, you can just join us on Panther Connect. And if you have any questions or suggestions, just shoot us a message through Panther Connect. We are there. Just type in AI, Artificial Intelligence and Coding Club. Our club should be there. And
quick question.
Yep.
Is there a way we can join? Is there another way we can join the club?
You can just email any of the board members. You can just email me or Ketul, Manas, or anyone. Just contact me after this session. I'll just add you onto the club.
Sure. Thank you.
Thank you. And today's chief guest is Stephen Lewis. Mr. Lewis serves as an executive director for technology in FIU's College of Engineering and Computing. Over the last 30 years, he has successfully led higher education IT research and instructional enterprise services for one of the state's largest engineering and computing programs. He manages cluster computing, network platform, and professional IT support services. Right? Mr. Lewis collaborates with FIU faculty, industry research staff, and government agencies on computing-related R&D via acquisitions and execution of millions of dollars in state, local, and federal funded projects and industry contacts. I'd like to welcome Stephen Lewis on the class. Thank you so much.
Thank you. Thank you, Latesh, for the introduction. Thank you. So this is like an auspicious moment. I'll take you back many, many years in my career, starting as an undergraduate. I had a faculty member, not unlike Dr. Anger, although Dr. Anger is a very unique faculty member, but a faculty member who wanted to see the students organize themselves into peer groups so that they can apply what they're learning in class. And he felt, or she felt, I should say, that the best way to do this is to focus on building a community around computer science. And so this particular faculty member actually started the ACM chapter here at FIU in 1986. So, I would first like to thank, on behalf of the school and the college, Dr. Inger and the founding board members for their insight and intuition for doing this, because I think the demand is there. So congratulations, Dr. That one event in my life changed the direction that I would go. My thought at that time was, okay, I'll just finish my undergraduate. A bunch of my friends are all getting hired by EDS, by this crazy guy called Ross Perot over in Texas. And so I guess I'll be moving to Texas, and I'll be working on some payroll company. Like that's going to be my life. That's where all my friends were going. And so fast forward now, almost 40 years. You're at this moment in your career where it isn't another COBOL program, data processing. We're well beyond that. We're now creating machines with the aspiration that they can essentially do things that we cannot. Keeping a checkbook, why do we need a computer for that? A human could do that, right? That's the common sense of the human man, right? But the things that we can do now with AI and the things that you will do with AI in the future is going to be amazing. And so I feel that your participation in this club, and nobody's saying you have to be here. You're doing this. It's Friday at 5 o'clock. What are we doing? We should be all celebrating another week of health and everything. But instead, we're here, and we're here because we have a passion for this technology, and we know that it will change your life and it will change the future. The direction that you are heading. So, I guess my final thought is when you get to the point of making the decision of what your next step is going to be, make sure you think about it in these terms, that over the next 10 to 15 years, about almost 80 million jobs will no longer exist. They just won't exist. I'll get you in a sec. But that at the same time, they will not exist. Why? Because AI will have replaced them, completely and totally replaced them. And the problem is, those jobs, from a university perspective, we're training those jobs right now. So I feel part of what you can do to contribute, so this is a thing that you're doing to help promote yourself and your career, but what you can do for the school is give us feedback. You know, help us to understand the potential that you're uncovering and discovering, because there is so much happening in AI today that no one single faculty member, no one single student can know all of this. But as a group, you can identify trends. You can identify opportunities for the school to expand what we're doing in the use of AI and machine learning. So we would love to hear your feedback as you begin this journey. And you know, and personally, you know, I'm a technologist at heart. So you know, feel free to knock on my door. I'm right over here at 282. And you know, we have a little chat, like they said, you have a little coffee, go somewhere. And I'd love to hear your story and what's your passion about this. And you had a question?
Yeah, so have you ever heard about automation? Because that is a complete reason why 80 million of those jobs will be non-existent.
And to that point, there will be another 90 million jobs created to replace those. It's not like we're taking all these jobs away from people. What we're basically saying is we need to start training for the next generation jobs. And that's going to be for you. And you're actually experiencing it now, so you have the ability to give that feedback to us. So when you graduate and you're alums and you're in those jobs, we want to see you back over here, you know, working with the next board that's carrying forward and giving them input and contributing to the development of this club. So very important, the topic that you're working on. So thank you very much. Last question.
Where do we stand with the first invention of the first actual quantum computer?
Well, the quantum computers already exist.
Yeah, it's
Google, check Google and IBM. They're in the head-to-head, and that's another rabbit hole that AI is going to absorb. So it's going to be amazing.
They're projected to outpace what the current computer can do. But the thing is, why is it not commercialized yet?
It's very expensive. Just like
that makes sense.
Yeah, just like in 1969, we did a moonshot to the. Like, why did they commercialize spaceflight in '69? Because it was ridiculously expensive.
Right.
But
that makes sense.
they're going to start to change. You're going to see that little by little, we're going to chip away at that refrigeration requirements. It's going to be amazing. So without further ado, I'd like to introduce our next guest.
Sure. Thank you so much.
So we're very honored to have Dr. Latesh Kumar. And thank you for coming to FIU and being a courtesy postdoctoral fellow in the Knight Foundation School of Computing and Information Sciences here at FIU. He is serving as a consulting cyber scientist at XPay PVT Limited in India. He received his PhD defending his research titled Implementation of Security and Deduplication Features of Parallel Network File System on Cloud Storage Systems from the School of Information and Communication Technology, Asia University, Singapore, Malaysia in October of 2018. And prior to this, Dr. Latesh was associated with major IT giants like Lionbridge, HP, NetApp, in a ranging role of software development to product manager in prime domains such as designing security systems for operating system in Linux, storage protocols for NetApp, and products for over 20 years. So it's really is a wonder to have someone who has bridging both worlds, the industry and as well as academia. So it's again a pleasure to have him here. He has published more than 20 research works in major publications at various famous journals, Springer, IEEE Journal, and has had, I think, quite a number of experiences that I think young students are going to be very interested to explore with him. So thank you, Dr. Latesh, for joining us and being with us tonight.
Thank you so much. Thank you, sir. Yes. I'd like to once again thank everyone who's present here and over the Zoom on this Friday evening. I'd like to hand over to Dr. Latesh. There's a joint workshop by AI, Artificial Intelligence and Coding Club and FIU School of Computing and Information Sciences. Thank you,
Latesh.
sir. Thank you, sir. Should I? Can I? Yeah. Thank you, sir.
So good evening, everyone here. Sorry for this. Thank you, Wishes, and thank you all the board member of this the new startup club, AI Coding Club. And my heartfelt thanks to Dr. Professor Iyengar and extreme thanks to Mr. Lewis for giving me a sort of a welcome note to start my kick presentation so that I'm talking to a technologist with his own kind of a future technologist, right? So with this, I'm gonna start with my presentation. The whole talk is very simple. This is not a theory subject which you're gonna learn in academia by any professor. I would like to try more on the industry side, right? Majorly, I'm gonna talk on three major domains. That's on operating system, networks and communication, and then little on internet. And I had one of the gentlemen here who wants to know more on quantum computing. I'll be talking more on quantum as well, which talks more on quantum security and quantum internet. I would come back to you maybe around 5:40 or 6:30. Please bear with me till then, okay?
Yes, sir.
Okay, so this is the title that we planned up. Initially, Yashas's team had something else, but Professor Iyengar wanted me to stress more on specific of the OS and internet, which are driven by AI today, okay? And as like Louis was talking, like very soon you're gonna lose lots of jobs. I too agree that there's nothing to panic, okay? You're gonna lose 80,000, but I feel if very well placed with a AI technique, with multiple domains like quantum in place, okay? I see like more than 160,000 jobs to be created. It's not that easy that we talk about on a losing job to just say like if you are a Python or probably a C program or a ++ program or could be a Julia or could be any other programming language. When we have micro teams at the industry, okay, there is a development team, there is a testing team, there is an integration team, there is a release team, okay, and there is a sales team, okay. Bunch of very small people are there. Why? Because everybody is given with a very defined job, okay, and over there are no data, okay. Things are already there. You're going to consume some library, write some program, meet the output. But when you bring in data, right, there are a lot of stages, right. The first thing is like when you get data, I don't know what is the data, right. You need a separate team to sanitize. Once the data is sanitized, you need a team to organize. Once it is organized, you need to channelize. So there is plenty of opportunities which are going to come and which are going to come like a big wave. And maybe like we all have to make our minds, by the time you get graduated, do not fix to a specific thing. I would say keep the AI as a core, but you got to channelize in multiple directions. To be honest, like 360 degree. You don't know to which area you're going to hit. So that's how the industry is booming at and moving at. The highlights of the presentation would be something on operating systems and internals. I'm going deep into the operating system, sometimes maybe kernel, and some techniques where you can break, tweak, stuff like that. And then which talks more on the IT admin side, which just like Louis and his team would be doing here at the FIU, and some bit of a coding, how you can inject a code into your OS, what damages you can create, how to crash on a hard disk, how to recover it, something like that. And maybe after some time I'm going to talk about the backend. Backend in the sense like if you have heard about big data centers, one of the things that I'm quite impressed with Louis' expertise is in clustering. So I'm also in the same domain. I'm going to talk more on a bit of clustering, how exactly cluster works in terms of setting up a big, huge, probably a cloud data center here at a Waltham, or could be at the California, something like that. And then I'm going to talk a little on network and communication. I just want to hear from you guys here sitting in the hall. Like, so have you all had sort of an experience in terms of hands-on in networks, or is it just like theory? At the moment, it's a theory, just to get an understanding so that what I have to talk, right? So that you get more knowledge, right? And then we're going to talk about internet and then security challenges of the current trends. And finally, I'm going to talk something on your future internet, that what exactly we are doing. So I'm quite happy that I got associated with Professor Iyengar about in 2019. Since then, me, Professor, and one more scientist, we are working hardcore on quantum internet and quantum key distribution techniques. I'm going to talk more on that. You have a question?
So, what would the quantum internet look like? Like, would it be so much more different from the internet that we have today? Like, for example, think about the quantum version of Google, quantum version of Internet Explorer.
Okay. So let's say I would like to send a file to you of 1 gig.
All right, great.
In general, how much time would it take?
Hmm?
In general, you got a, let's
Well,
say, an i7 series of a laptop,
That's going to take a lot of time.
right?
But if we use quantum, it's going to take less time.
It's done. By the time you are discussing, it's done.
Seconds.
Yeah.
Or nanoseconds if it
You're right.
even exists.
You're right. Right. And then at the end, I'm gonna drive something where we don't know, as Luis was, just made a statement saying that anyone from this hall could bring in a new feature to AI, to FIU as well. I was gonna throw a lot of light how you can use AI to come up with your own AI-driven operating system. So these are the highlights of the presentation, and if you're all through, let's get started on this now. Okay. So let's start with a unique understanding. I'm going to say something like, what takes away a word called one? It's not a question, so don't feel I'm a professor here. I'm just an IT guy just like you, okay? What takes one? Got it.
Binary.
Cool. Most sophisticated, most sweet answer for me. You have to think very simple, just like a very dumb program which is giving lots of error to you when you're sitting all alone in your laboratories. Okay? Be louder, there's nothing to worry, right? Computer? Okay, one more, getting close. Help each other, right? They're just a team.
-1.
Huh?
-1.
Still not happy? Still not happy?
Okay.
Okay.
So the question is, what takes away one?
Yep. Anyways, I'm also part of you guys, so I'm gonna answer myself. The letter G, gone. So I say, whenever you want to fix problems, okay, you have to think very, very simple. Very simple. The most simple you think, most easily you can break the errors. Most of the time what we do when we code, either through your AI, or could be Julia or any other programming language, we look at the error, right? We look at the long error message, but we never look at the code, isn't it? We don't look at the code, we look at the error message, and we bang our heads. Okay, this error is, and then hit Google or anybody who has done a lot of activities on that. And then after spending a couple of hours, we realize, okay, sorry. So after spending a couple of hours, we notice that, okay, this error seems to be connected to one of the alpha numeric, right? Then you fix the problem. But in general, you take any programming language that is available in the IT or in the computer science domain, okay? Every error is predefined to your code, right? When you first take the guidelines of learning a programming language, much before when you study the headers or namespaces that you call. Let's say import OS or hash include std_zip.h or hash include some other header file. You have to study the header files or namespaces or classes. When you study them in detail, you get to know what are the codes that we have. All that we do is somebody has written a function, I just invoke it, feed some parameters it, and it works. But most of the time, I myself say what parameters I have to supply because I'm learning it. So I suggest please use the error code understanding first and then get into the programming. So that gives you lots of confidence and quicker way to write programs. Okay, so how many operating systems have you heard about till then? Just in the heart. I start with, okay, go ahead.
Windows, Linux.
Windows and Linux, great. Any other operating systems?
Mac OS.
Great.
Unix.
Good, cool.
Technically,
95.
Android and iOS are also mobile operating systems, right? And
Cool, cool. That's a trend now. That's a trend now. Yeah.
Windows 95
Back in legacy. Okay.
Yeah.
I would like to listen the history stuff rather than the trendy one because the moment when you hit Google, you get the trendy ones, right?
Right.
Right. So if you can name me something like which is old, but they are still robust.
Unix.
Okay. I heard multiple times everybody says Unix, well that's really good. Okay. Have you heard about something called
Oh, MS-DOS, yes, I
Cool.
watched it.
Okay.
I watched the Bill Gates documentary a while ago.
Okay.
Yes.
So that's your Microsoft Disk operating system, right? So that's for the, let's say, first operating system, to be honest, right? There are a couple behind, but that did not work out. But MS-DOS is the first one. Today you might be, having wonders of wonder operating system, and the base is this. You have heard like loops in your programming. You have got conditional constructs in your program, and you got like you're gonna modulize or you're gonna partition your programs, right? All those were there in this. How? Many times to do some configurations on your box, what do? You just click start run and then CMD, right? You get a small black terminal window. That's your MS prompt, right? Most of the time you just only do basic commands, right? But nobody knows you can program. What your C or what your Python can do, this can do. So that's the capacity of the MS-DOS. And today's whatever the Windows booting that you will experience, right? It's given from here. So that's why MS-DOS is a foundational operating system in terms of Windows, not in terms of Unix. Okay? Let us be very specific. This is only foundation for all your Windows-based activities. Okay, as is all climbed Windows, yes, there it is, and then Unix. Many people just occurred that Unix is operating system. True, but now Unix is there with legacy, old organizations and old companies, but most of them have moved to a newer, a variant called your Linux. Okay. So I'm going to talk more on Linux. I've spent close about 16, 17 years on Linux. I would be happy to talk more on Linux. Let's talk about some basic differences of these two operating systems. Okay. Let me start with some basic stuff, right? Most of the time, let's say I'm going to use a simple Python code to such a file. Let's say you're going to write a simple code to such a file using your Python, and you call up your file system, say input, within enter the file name, and then supply it to your file system variable of your Python. Now it searches the file, right? Let's say on Windows, from your Windows operating system, I would like to find a file from 1986 year, and I've forgotten the file name. Have you ever tried something like that? This is what's going to happen when you start doing your AI. In future, you got such amount of data, you don't know which part of data is lying where, and you need smart tools which can just pick the data like this and give to me. Otherwise, You all know at the moment AI consumes a lot of a computing power, and it also requires large amount of computing nodes in terms of it could be your heap or RAM, or could be a parallelly placed active clusters or passive clusters. So that's the reason we need smart tools. So coming back to the question, how do we search? Most of the time you just go to your Katana and say, hey Siri, find me this file. That's what we all do, right? But there's a different way. It's there in Windows as well, but or in Linux, it's quite faster. I just do a simple command called find, and I said this slash. This is root. Root in the sense you say like seed, right? Something like that. Or in Linux, this is the structure. I'm going to explain this a little later in detail. And I say minus name. This stands for file. If I don't know the name, I wanted to search my file on the year, right? I'm going to say year, put 1986. It gets the file like that. And this is just a one parameter that I'm giving there. Like this, you have got more than like 40 different parameters. You've got access time, modified time, right? Type of the file, whether it's a character file or a block file, or maybe category of the file, contents that you have inside. I remember like I wrote something like maybe a storage box content. You can write that pattern into search. So that's such a different factors that are connected with your Windows and Linux. These are some internal differences. Now if I talk about the core differences, what exactly the core difference of Windows and Linux is? Yes, both are specifically not operating systems in the sense, most of the time the Windows that you use, right, we tend to call it as operating system, but I hate to call it as operating system. Why? Because they are purely not. They are like your environments. They are integrated application environment. What exactly they do, right? You install an application, it just accepts it and allows you to work. That's how the job it does. As a user, right? Basically, when we say operating system, it manages your user, devices, memory, another thing. That's all. But when you talk like a larger or a complete operating system environment, it has to do a lot of functionalities. So that is the reason, right? Many of the Windows variants are just called operating environments rather than operating system. And when initially the operating systems were built, there were two architectures. You never come to know all these things when you use Windows. But when you have Linux, you can just write a simple command, uname space minus I or uname space minus A. It gives you complete details of your architecture, hardware inside, what's the kernel parameter, right? What's the spin engine in the kernel, and what version of release that they got. Such larger data that they're going to get through this command from the Linux perspective. Okay, so have you ever heard something like multi-user, multitasking, and distributed? You got a Windows box. Let me give you an idea like this. You got one Windows box here, okay, in your lab. You come in. Louis and team already have given you the access. You say Control-Alt-Del, put your username and password. You get in, right? Let's say I would like to log in one more time on the same box. Is that possible? On your Windows box? I would like to log in. Let's say Ashes has logged in. Now let's say I would like to invite Louis to log in on the same box. Is it possible? On your Windows? Have you ever tried that? Something like that?
At the same time?
Yeah, at the same time? No? Good. That's what Linux does. Okay? Linux is such capable. On your Windows, you can have only one session. Yes, there is another way. If you have got CAL licenses, remote desktop services, you can have multiple sessions. But on the same box, if I have to have, let's say, 7 logins, that's only possible on Linux. How? because Linux works on terminal type sessions. Though you have graphics, you've got something called terminal sessions. I'm going to talk a little later, maybe in a couple of slides ahead, how exactly it boots, what different features that it comes with. Why such type of features are always required. So that we call it as multi-user. Basically, there is this Windows box, you have installed something and there are multiple people that are connected with CAL license and they are working. They call it as multi-user. And multitasking is something like you write a simple program and your program is segmented, it goes to different area and there are tasks happening. This is with single process thread. But if I say there are multiple users have sent me a jobs to work on, so that's your multitasking. To give an example like context switching, you're playing a video, you're connected to an internet, you're using a browser, things like that. So these ways you can have multiple operations on this. Okay, then the next is something called your distributed operating systems. So how many processors in your box you have heard about? From your, let's say, that box, Mac box, single processor, and my laptop, and HP one, single processor, right? Different processor technologies that you heard, Hi-Fi, i3, i7, stuff like that, right? Have you ever heard one huge game server which has 256 processors? Okay, these boxes we call it as pods. Okay, if you think, and when you get into the IT industry's back-end data center, okay, you're gonna have processor trays. And each processor tray is identified by a unique identifier, that is 16-bit identifier. You can literally cut your processor. And each processor that is partitioned, you can assign a job to that. That is the reason you say Facebook.com, it just comes like that. It's not about connecting multiple nodes, it's connecting about such kind of huge rack servers. We call it as rack Spark boxes. Who are those examples? IBM AX, Sun Solaris, Sparks, and HP Unix. So these are the operating systems. They are highly distributed and highly powerful. To give an example, like today you might be having an idea of booting both Windows and Linux in a single box. Have you ever tried that?
Yeah.
Cool, that's good. Isn't it fascinating one? Just doing by a contact switch, you can get into Linux and you can come back to Windows, right? And sometimes when you're just trying to have an installation, it is also fatal that you have lost your disk as well, right? Many times when you attempted on your own, without knowing how to place or where exactly you're supposed to place your MBR, your whole hard disk is gone. But now, after some time, VMware is a company which started with your, just place a simple application, put in a CD, and then you have got your Windows and you can load operating system. But you know where this root thought came from? That was from an operating system called Solaris. It's a original distribution from your Sun systems, way back in. So I'm talking about somewhere around 85, 86, 87, 90s. So they are the one, they came with box, it's a huge box, and they got a, now you're gonna check, if you wanna play your game, like PUBG or whatever, you're gonna insert an additional card, right? Which gives you a booster effect of either spotting somebody. Or there in that hardware, Sun Solaris, there is a card called PCI, right? Peripheral Controllable Interface, which has the directions to understand the Windows operating system, right? Sun Solaris used to boot, and there are some control settings. When you choose that, you can install Solaris, and they could do the both transaction. Till date, the biggest, the 5 servers that you have ever heard on Earth, they all work on this operating system called Solaris. Even for the matter, like whenever you go to your ATMs and then swipe your ATMs and you get your, withdraw the money, and then end of the day you get a small check, right? The check, on the check, if you don't notice it actually. Whenever it fades, we just look at this and we abuse this and then scratch it and dump it to recycle it. But if you pay attention, it says a protocol NFS, that is from this. So that means your transactions are communicating to a Solaris server, network file system. Sometime later, I'm gonna talk on that as well. So this is about the CPU partition that I've talked about, and there is something called active and passive. What exactly active and what exactly passive are? Active in the sense, let's say I got 3 core processors here, and I have given it for FIU. And there are other 3 processors, let's say I've given it to something called University of Florida. Now, if one of the processor in FIU goes down, right? If I have set the clustering activity, the other processor will automatically support that activity. So that is how, right, the active and passive clusters operation happens. I might show some small configurations maybe in the later slide if I'm not gonna miss it. And there are other applications and cloud servers that you're done. By interest, like anybody has developed your own application hosted on your laptop, just like an IaaS or web server or something like that? Like, have you created your own applications to host on your own servers?
Web server.
Web server, yeah, you're right. You're gonna, usually we say it like IaaS, but you guys name it as very simple, web server. Anybody has tried something like that? I think you guys, oh, that's good. So can we have your experience? What web server did you use?
I think I use Netlify.
Okay, cool.
It was to host a Flask web application.
Great, oh, that's interesting. Okay, so I suggest start writing your own application and start deploying by yourself. You understand more. So you'll understand the core of the internet and core of your application. That is always feasible. Okay, looks like it was quite boring for some time. So let's have a quick way. So now you tell me on your experience, which operating system boots fast? Very quick. How many of you say and how many of you say Windows?
Mac OS compared to Windows.
Okay.
Windows or Linux.
Okay. So if it is Linux, how many seconds does it take? Because lots of answers here. Kids are very smart here. Okay. So
8 seconds, 8 to 10 seconds.
okay. Any other answers from you guys? Okay. This goes to you. It's good. I know it could be a vague guess or whatever, but that is true. But that is true. You check out on your Windows and you install a Linux box, it boots very quicker and faster. How? Let me tell you that. Why? When you start writing programs next time using on a Linux box, you please pay attention how you can make your program faster, especially when you're using your Python and Kaggle dataset. Have you ever used Kaggle dataset?
Yes.
Most of you, right? That's a free source that you are able. Ever tried on Twitter? Twitter APIs, Google APIs? Great. Okay. Now next time when you use your Twitter or Kaggle dataset, if you're loading it on Linux, okay, you're gonna experience more smooth, more seamless, and quicker. How? Let me tell them. Okay. Here it is. I just run through Windows so that you are all Windows experts. True? I believe that. Okay. So when you just power on your box, first is post, that is power on self-test. It checks all the devices, they are getting adequate power supply from +5 to 5 volts to +12 volts, sometime here and there. And then you got your BIOS program. It takes care of all your basic input-output systems connected to that, because the INT, your interrupt signal, sends a signal, make sure all through, and then it goes to your config loader, which loads all your basic Windows architecture, because you have got any other devices, it supplies all the system files, and then it goes to your boot manager. Let's say this is your hard disk for like 1 TB. Okay, it reads this 512 bytes, which we call it as master boot record. MBR. This is the area it hits in, and it reads the program from which area it has to take the booting agent from your secondary system, because your operating system is stored in hard disk, right? It has to take that content, put it onto RAM, then only the operating system boots. Otherwise, no operating system will just boot by themselves. So you're going to put this couplet here, the OS boots, right? For this, you know how much time your Windows take. Now, coming back to Linux. Okay. First, this programs are standardized. You cannot change anything. After that, the Linux has something called boot init RD. We call it as init resource disk. It just takes the disk and says, please check how many run levels I have got. Okay, I'll tell you what exactly run levels are. It goes to all the run level and then ends up with a program called rc.local, gets up your screen. That is your login. Here there will be a program which is running called span, which takes care of your login activity. So have you tried logging into Unix or Linux box with a terminal windscreen? Right? You tried, right? If I supply a wrong username here, what would happen? Right? Does it say a message like that? No.
It goes back to using.
It goes back to the same process. That's called spanning process. Spanning in the sense when you get into Twitter, what happens? Right? It just gets rolled up, right? That's why it does not take too much of a load. When it says your supplied RAM, I don't care. I just log it onto my logs and then I'll send you a request. That's why. But however on Windows what does happen? You got an application interface, it goes check your PAM or SAM DB, it comes back, tells you that, hey, there's an issue, you are not a valid user, right? Linux is not. It's a big ocean, sits quiet, you keep attempting me. Until unless you are a genuine user, I'll let you inside, otherwise, walk off. So this is how this Linux booting process happens. Now, why people always tend to use your Facebook, your WhatsApp, and recently we all follow Netflix, right?
Yes.
Cool. Do you know what operating systems these big
Windows.
vendors they use?
Microsoft. Windows.
No way guesses this time because you already started learning Linux now. It is Linux specific. Very good. There's one answer. Any other distributions you have heard about? Fedora, Debian, Caldera, SUSE, News. There are plenty of Linux. Have you ever heard something like FreeBSD?
No.
Okay, this is the one they're going to use, right? Even your VMware is also built using this, right? Why? It is because, as I said, run levels, you can see here, I just let you know, 0, 1, 2, 3, 4, 5. These are the run levels that a Linux box has. I'll just run through quickly so that next you can write a small script like that. But you guys don't have access to it, right? And then we're going to have more oral session. I thought like, if I got Python, I can just get you connected and give some small script so that you can play on it. Okay. 0 is something like, you're going to say shutdown. That's called power off. Okay. 1 is something like single user mode, right? So what exactly a single user mode in Linux operating system is? Assume that you lost a Windows box password. What is the best thing that you do? Contact Lewis and team. That's official, right? Quite legal, right? Is there any way that, have you ever tried on your own? Not the campus boxes, or your personal boxes. Have you ever tried researching or breaking up your root administrative passwords by any chance? No? Give a try on your personal boxes, not on the campus boxes, okay? So that you're going to learn something, right? So on Linux, we have something called safe mode, right? Or recovery mode. When you do a abrupt shutdown multiple times on your Windows box, it gives you an option. You would like to have a safe mode with networking, blah, 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 stuff like that. Just like that, on the Linux side, if you choose run level 1, it takes you to a single user mode where you have only minimum services loaded. The services which are required for operating systems to just settle down, and then if you say PASSWD there, you can change the password. Now since you know this, right, anybody can do that to your box, right? Let's say I come to your flat, Duke Studio room or whatever. I know you're not there and I'm allowed inside. I can boot your box and then get into single user mode, change the password, access the data. How do we protect, right? So that Linux has an alternative there. Okay, there is something called PAM, which are called pluggable authentication modules. If I set my code there, you cannot come into single user mode. I'll block you. You are stopped there, right? That's how it works. However, if you have got an external CD drive or an internal CD drive, your Windows can always be broke. I can have a boot recovery mode, get in there and then destroy. But that's not possible on Linux side. Third one, second is multi-user level that I talked about. What exactly multi-user level? Try this on your Ubuntu boxes as well. Boot your Ubuntu, you will be on X session. That is usually on F7. Control Alt. Hold Control Alt from your keyboard and you will be on F7 session. Other than that, you hold your Control and Alt. From the keyboard you hit F2. Okay? You get a black window. You log in one time with some other user which you have created. Again you say Control Alt Del, F2, F3, F4, F5, F6. You can log in multiple times. That's how you can have multiple users logging into the system. Now, let's say you would like to increase it up to your F12 key. There is a file called /etc/anytab file. You can just Google it. Go there, add the number of sessions that you want, reboot the box. Not even rebooting is required, just restart the service, your sessions are active. So that's what your multi-user levels are. Over here, you're going to have only 2 sessions, that's your init 2. And then init 3, you got all your sessions and some basic file systems, which is available. I'll talk about file system a little later. And then 4 is the unreserved level. Maybe over here, in future, Louis and team are probably, if you are working with your own, patented product and you want to start up your own operating system, either it is AI driven or something like that, okay? How to charge up your operating system. Let's say you're going to come up with an operating system where everything is just voice oriented, maybe in future, right? I'm going to say boot, the system should boot. Then I'll say go start, load me the document. It starts writing, okay? Delete it, okay? Close it, play the music, something like that. We don't know, it might come in future, right? So let's say you have built that. Now, how do you show this to the world as an operating system, okay? Then on Windows, it's a copyright issues. You have to go, talk to them, pay dollars and then do it. How about in Linux? It's quite simple. Download any free BSD, there is something called GNU, Group Not Unix. You register there, you get a free ID and download this version, okay? And the level that I'm talking about here, it has nothing, okay? Now you keep your all operating system content here. There is a way to build the kernel, build it. Let's say I'm going to take a name called Lawrence. The operating system is AI Lawrence, boot it. Next time when you compile and boot, the operating system boots like AI Lawrence. You can start selling. You don't need to pay royalty. That's how Linux works. And this is possible. Okay, just do kernel compiling. It's very simple. Maybe 5 to 6 commands. If you got your program ready, put the program in this level, compile it, it happens. Was it like boring? Is it okay? Cool. Okay.
Yeah, really nice.
Thank you. Let me go ahead. And the same thing is not possible with your Solaris or IBM AX or HP Unix because They also bought their this Linux distributions, and let's say whatever the hardware or whatever the device-based applications that they have got, they are going to interface into their system in the same run level 4. That's an example of how operating systems are, different operating systems are booted and how they're going to work. So I suggest when you develop your code, okay, make sure you pass each of these levels. Okay. Okay. So how many programs have you written till date? If you remember the count. 50, 100, more than that? That means FA is giving a lot of load. Okay. Maybe like 200, 300 programs easily. Have you ever counted the lines? 15,000? 1 lakh? A million sometimes? Right? Now, having said all those things, if you assume that you have written a 5,000 line code, right? Have you ever checked the memory? Have you ever noticed the time that your program is consumed? Though it is 5,000 line, maybe your Python would just do 2-3 circles from your Google Colab or so on. The program is run, right? You don't feel even seconds. But imagine if you are part of a data training system, okay? And I got 2 big cloud data centers that we call it as cloud harvesting, right? Whenever you start working on AI, okay, it's not about a single data set. You are working on multiple data sets. There will be one cloud here and there will be another cloud here. That is a situation that we're going to experience in future. You would like to move some data set from here and some data set from here, right? When you put a request, right, most of them, they come from the storage. They don't come from your hard disk. At the moment, since you don't have that, what do you call, infra with you, you'll be using your data sets directly from your Kaggle or something. But when you get into real-time development, okay, they are on 2 different cloud data sets, right? To pull them, right, you need an environment. So what is that environment, right? The environment is how quick you can access the data, right? You might write your own instructions with the standard guidelines that is given in either in Julia or Python. But what is that you are supposed to see? You are supposed to understand your code or the instruction that you are placing, right? How quick is able to get the Kaggle data set. Many of the times we don't understand. I just write, I copy the instruction standard and then put it, and then I feel like Kaggle is doing and it is getting to my PD or whatever, you call up your functions, it happens. But we never notice, does it really taking less time or not, right? To become a successful developer, the first most thing that you have to worry is keep less time in fetching large data. That's a primary agenda of a developer. And then compiling capacities, which you don't need to care if you have your Linux box. Just a sort of understanding. Have you ever built a private or public key systems or operated on a large database? Simple MySQL or MongoDB or any databases that you have attempted? No, you haven't? Okay, just give it a try. Or else you can write a simple program. Everybody in the room have written a program on file handling, right? File handling? Right? Just say like you say, file pointer, open a file in write mode and start dumping data. That everybody has done, good. Have you ever written a program to destroy a hard disk? Not, right? Try it. Not on your personal hard disk, not the public one or the campus one. Try it. You see how much time you need. It's not easy. It's really not easy, right? You say like my program just run like this and give me the output. But when you try to destruct a device which is part of your operating system, it takes a lot of time. Experience that, and I'm going to share my email ID at the end of the session, and then write me your output or the challenges. Further, they're going to help you on that. And the next one is your DLLs. Anytime if you have written web applications or anything, have you used DLLs, dynamic link libraries? Heard about something like that? DLLs? If you have used a web-based Python application or a .NET application or a Java application, usually these things would come. So basically what are these DLLs, right? So they are the one, they just promote your operating system. Just do a quicker code compilation, okay, then time-saving activity, connecting two different activities in the operating system, right? Let's say, to give a best example, I'll gonna write a program which connects to Twitter, and when I write something into Twitter, it directly goes to FIU-DB or FIU, one of the web portal. So what I need an API, which we call it as application interface. So when I use the instruction for API, what happens? It gives me two sockets, two open loopholes. One goes to Twitter and one goes to FIU portal. Okay. Now, who will manage this? You know this. You are writing the code for these two, but from the operating perspective, right? DLL is the one which connects both of them. So that is the concept of DLL. And for sake, DLLs are good to some extent, and at the same time, DLLs are too vulnerable, especially in Windows. I'll talk this more when I get into the security slides, right? You can do a lot of activities on your own DLLs to send some Trojans to somebody, send some malwares to somebody if you are connected on your network. Thank God it's not possible inside the FI network because they got very good firewall and plenty of rules to take care of that. And next is something called your decode executable files. How many of you have written C programs here? Most of them. Oh, fantastic. That's really good. Okay. You have received a file called exe file, right? After first compilation, you get your object code. Second compilation, you get your executable code, right? Can you bring back your executable code to your source code? Most of the time, we always do forward engineering, right? Now the time has come to do a reverse engineering, which always Professor Iyengar tells me, okay, Dr. Latesh, you do something reverse. That's where you're gonna, learn something, right? I suggest when you write your code, you get the output. But when you do a debug on your exe file, I can bring back my code. This is how, back in those days, the attacks were used to happen. Most of the time, the attacks are feasibly on exe files, right? Or .com files. But if you do a debug and choose any exe file, it gives a 4-column, okay, decimal values. After passing couple of rows and columns, okay, it will give you something called literals and the other thing I forgot. It comes in your system ADA subject, literals and labels. Whatever the data type that you have used, everything can be seen. From that, I can start reconstructing my program. So in the recent versions of Windows, they have officially blocked this debug, but you have the older version of Windows, you can use this command and start doing whatever you want.
Is this a good time for a break for some
Sure.
Coke and all those things
Sure.
for everybody?
Yeah.
So why don't you have a little Coke and then we'll serve you. Okay? Please, just take 5 minutes. Please. Thank you. Have some Coke and please.
That's not a long presentation.
Good.
I'm not a computer major myself. I'm a physics major, but I
Are
just
you
want
liking
to.
it?
Yeah, I would just want to find ways on how we can reinforce our cyber infrastructure.
Sure.
Because our cyber infrastructure is weak, and I feel like if I have a strong background in programming, I can do that. I can find a team to help me.
Maybe you have to just wait for another 5-10 minutes. I'll get you to the cybersecurity stuff.
Yeah, it's because, scammers, right? They will call via certain servers and then to all the way to the person's phone, asking them for money, usually from third world countries,
Okay.
Yeah. But you know what scammers are, right?
So you're basically a physics guy, I understand.
Yeah, but in physics, we use Python for data analysis.
So, have you ever done something on photon radiation, photon transmission, something like that?
Well,
Hey guys, thank you very much.
Well, we're trying to do experiments right now. Well, we're in the beginning stages of my lab. So, yeah. Thank you, sir. Sorry, man. It's okay. I'm sorry. Awesome. Thank you, sir.
Sandeep, what is it? Oh, thank you.
Okay, we can go ahead and start.
Yeah.
Bring them. Tell them to come.
He's back.
So, after understanding like the OS, the programming, and bit here and there, let's get into slowly one more step into your files, file system, and then a coding. Okay. So let's say you got a hard disk. Assume that you got a hard disk on this board, and you got a drive partition called C drive, and you have a file called kfscis.txt file. Okay. If I hit delete key from your keyboard on selecting this file, right? What happens to the file?
Did this move to your second recycling?
Cool. So if I use shift delete, okay. Now let's say I'm going to apply the first thumb rule. I selected the file and then I did hit del key. As per you, where it goes to recycle bin. True. Now if I do empty and recycle bin, what happens to the file? Can I recover the file from that recycle bin?
Yeah.
Once it is empty?
No, once it's empty.
I think some forensics can be done in the system.
You give me $5, I'll get your files back. That's how the storage is all about. Yeah, you got something?
When you delete the file, is it still on your hard drive?
Can you be loud a little bit?
No, isn't it still on your hard drive as long as you don't overwrite the memory?
You're right. You're in my place now. Okay. Your file never gets removed from your disk. It happily sits for a long time. There is a master way. Only when you apply that destruction way, then the file is completely erased from the disk. Else, the files are always permanent. So that is the reason whenever you dump or throw your magnetic material, it could be a thumb drive or a tag drive or any storage devices, okay? You have to apply that technique and then throw it. Else, the content can always be recovered, which I'm going to talk about, okay? How exactly those things happen. Since I felt like I got two answers from here, then I have to hand this. Guys, have fun. So now I'll talk how these files are available, right? Let's say I ask somebody to create a biodata, right? You create my name cd.doc. Why do I have to name the file? Because so that I can identify this file from the whole file system, right? When you close your box and boot next time, and then say you search from your Windows search bar my name, it gives you a lot of list matching to the literals that you typed, you get your file. Now, how did operating system record this, right? The operating system for users, for end users like us, are applications that we use. For them, there is a mnemonic way of identifying the files. But for an operating system, there is something like this, which we call it as inode. Any time when you create a file, okay, it creates an internal data about data, which we call it as metadata, that we call it as inode. For me, my name doc, but in my operating system, okay, it would be some long number. And this is an attribute which is stored in the system. What exactly it has? Can you see here in this small water board? You are placing your data, and data is placed in inode. So whenever you open your file from your whatever the operating system, they point internally, the operating system will go to inode. The inode picks up the value. Now let's say you removed your data, correct? Earlier in our past example, you removed a file, where it went? Recycle file, right? That doesn't mean to say your inode is still not removed. What is that? You removed only the file system's label. Label means what? For your understanding, whatever the name that you have placed on the file system, only that is erased. Okay? But your inode is still happily sitting, right? Now, when you remove it from recycle bin, okay, this inode gets an update that, hey, there is a file. It was there in this location. It moved to this location. Now I see somebody is asking me to void it. Void means not accessible, right? It places a pointer called, we call it a sticky bit, okay? It places a small character called T. That means it's a toggling bit. Now it's confirmed that your file cannot be accessed by you once it is lost from the bin. But if I am a storage expert, I know still this person is still there in my hard disk. If I open my third eye, I can map that inode, get your data back. Okay? And such hard disks are there. Even if you crack your hard disk 2 pieces, I will get your data back. It's quite surprising and amazing. You got your flying objects, they hit, right? Your black box. How would they preserve data? That's what the storage from NetApp. So I spent 4 or 5 years there in the disaster team. So I'm going to talk more on that a little later. How to preserve the data, what technology that they use from the Myla material, which you call it as your hard disk or memory, whatever that you have, how it protects that large sheet, cracking, and even when you cut one portion of your disk, when you, there are, in the disk you have like cylinders, sectors. When you read the hard disk, it is cylinders and sector. How when you cut one portion, how the other sector just copies the data to some other sector. How this random is just like your AI models, something like that. So then after that we have got something called super blocks. So what are these super blocks? Super blocks are the next bigger monsters. They eat this kind of multiple inodes and keep them inside. I would like to recover a complete hard disk. Then what I do? I just touch super block. In your computers you got C drive, D drive, blah blah blah, many alphabets, right? So each drive refers to one super block. That's all. So you lose your label, but I got my drive. You partition your D drive. If you wanted to install something, okay, again you rewrite. The previous data is still there. Okay. Go ahead.
When you said, you keep saying hard drive, does that also include SSDs? Or?
Yeah. Recent flash drives including?
Okay.
Yeah.
So after adding more data, deleting, adding more data, deleting, so eventually the storage then gets lesser and lesser.
Absolutely. Very good question. That's the reason you need defragmentation. Right? So you might have used defragmentation on your Windows, right? Just like the COVID came in, you got your Moderna and Pfizer just to sanitize things. Similar way, hard disk, they got their own internal tools, which nobody talks. They got their own tools. Before the hard disk gets a choke or a heart attack, it helps himself to fix it. Only when it fails, but thinner area, bad sector area, stuff like that, then it surrenders saying that, hey boss, I cannot do anything. Now you are on own. Then you get your dirty blocks, which you call it as B. Use a CC cleaner on your hard disk, install an application called CC cleaner, run it, and choose a hard disk. Wherever you feel like a long time writing or reading, there it shows you B. That means bad blocks on your hard disk centers, right? So these super blocks are the one they just preserve this full hard disk data. By using that, there are some commands. I just let you know. Tune 2fs. This is a Linux command. If you run this command, it will give you complete structure in one drive. How many directories were there, who created, when it was created, what files were there, how many times the file was deleted, how many times the file was updated, all diagnostic data you get it from this, right? And most of the recovery software that you have in backend, they are all on Linux side. They are not from your Windows side. Your Windows is only good to write documents, play movies, do chatting, nothing else. Okay. When you click a C drive, right, it opens a window with lots of yellow folders, yellow color blocks, right? So what do you call them? Directories. When I click that, right, what is that action called? Open. Good. That's on Windows side. Can you come on Linux side? Create means like I have to put some label. What action happens actually? When you click on open, what action happens? Is that a read? Is that a write? Is that an execute? Are you sure?
Open it, so it's execute. Right?
It's always execute. Okay? When you click anything, an action, right? It is execute on. What is read? Read is something you say, hey, you go there, read the content from file system. That is a different thing. You are saying here, open it. When you are opening it, you are just getting all the inodes that I talked about here. That's what happens, right? Now we're going to talk more on your file system so that you get more idea what exactly file systems are, right? So now I got the backside board is completely white, right? This is completely white. If I want to write anything any piece of information that I want to write on this board, okay, I can start wherever I want, because the whole board is blank. But what we do, we create rows and columns. Why? So that it looks good, people can understand, read properly. Just like that, any operating system on the earth, it only helps you to have the file system to place your data. Nothing else it does. Very simple job. How does it does? Let's say you created a Python program or a Java program, and your program, you save the program. How do you do this? Either Control S or whatever the technique that you do. The moment when you do Control S, right, file gets saved. Assume that your file size is 4.3 kilobytes, your source code file, right? Do you know how exactly it sits on operating system? You never know, right? That is the reason earlier in my presentation I showed up, whenever you create your code files, okay, why they preferably say have modularization? Because the number of files that you place which are interconnected for compiling should be placed well within the blocks, so that your file system can pick it very quickly and your program runs faster. So how it happens something like this. Let's say this is my 1 TB hard disk, and I would like to run a command called formatting. You do your right button and format, right? You never understand what format your Windows does. But in Linux, okay, you can use a command called mkfs dot, just for the namesake, you just hold this for a thought, extended 2, extended 3, and then right now it is 4, and then JFS. I'll talk about all these things. When you say extended 2, right, you can say in my whole hard disk, how much of space, right, or the layout that I have to create for my files. Something, if I say minus T, if I say 8K, that means if this is my hard disk, it creates 8K blocks in the whole hard disk of 1 TB. When you put your, or when user starts using the operating system and he starts dumping the file, it starts loading 8 KB at a time. That's how the file systems work. But now can you realize, on your Windows, what is that you do? Happily select right button, just say flush off. I never understand what is happening and how much I'm going to store. This is the reason you have to do defragmentation and again and again and again. That kills the quality or the lifetime of your disk media. Okay, so that's where this function works. And you got plenty of other different ways. You can just do a man on MKFS. You get many things. Now over here, there are two major file systems. Actually speaking, Linux has more than 67 Linux file systems like this. Windows has got only 3-4. First started from FAT, then FAT16, then FAT32, and then NTFS, and then you got HPFS and other file system. What is FAT? It's a file allocation table. The way I just explained, it just allocates the file in the table, right? Then comes the 16. That means in your drive, you can place maximum 16 directories. Root, in the root. Not limited, okay? Don't take the explanation wrong. I create one directory here called A. Inside this, I'm going to create B, like this, 16 cyclic directories. If you go beyond, then the FAT table is cut. If I say FAT32, it's going to go bigger. But they are not shared. The way you're going to share your file from one lab to other, that's not possible in FAT32. There's a new technique that they introduced somewhere back in 90s called NTFS, Network File Share. That's a file where you can select one of the folder, go to right properties, share, name it, it gets shared. Just like the way you do it in Google Drive, right? That was a trend back. The same thing is copied. But all these things are by default in your Linux. And how it helps in recovering the data. Let's get into the business now, how you can recover your data. I'll just quickly run through. If you have got questions, stop me here, because I'll have to rush. There are a hell lot of slides, I'll have to finish them. Okay, this is my Linux hard disk, and first 512 bytes always reserved for booting. Okay, you can, in any person on this earth, when somebody asks you a question, in any hard disk, 0 to 512 bytes is a standard rule that it is always fixed for your MBR, master boot record. There are split partitions here, 64 plus remaining, it does its own operation. I don't want to go not in detail on that. Let's say there is a file here called test.txt and the inode number is 16,80,000 and some number. Okay, and this is there in a folder called AI coding. Assume now from Linux I do a command called rm to remove, supply this file name, file is removed, right? There is no recycle bin Linux. It's direct for short, right? Or sometimes you can create your own folder called /temp. It sometimes, based on that on larger production, they don't want to lose the first chain of action, they'll create that. Otherwise, it directly goes. Let's say you lost the file. Now how will I recover, right? So what I do, I say there is a command called Fdisk. Please do not use this if you don't, I'm sorry. Do not use this command without any expertise. It is quite directly into the kernel and to the file system. It might lead to loss of your file system. Okay, say -L. Okay, it lists you the complete file system. I'll just show you after some time. I'll show you. So this lists a lot of file system. From there, if you say, usually it will be like this /del /sda or sdb, hdb, hdc, something like primary, master, so on things. Now, let's say in my hard disk, it is sda. I'll say fdisk /dev /sda. Now it gives me the complete file architecture. From here, I say tune to fs and pass this. We already discussed when I use this command called tune to fs and /dev /sda, it lists me all the super blocks and inodes connected to it. And after this, from here I run one more command called dump to fs. From this, when I run this command, immediately it shows me all the files that I've removed from the inode data. Because I don't know the inode, operating system is the one who knows inode, right? Then what I do, from the dump to minus command, I say -a, that is alphabet, okay? Then it says, hey, I think I removed a file called test.txt, okay? It gives me the last character. Just to make sure you are the owner, you are trying to recover that file, okay? I have to input my first alphabet. There is a symmetric algorithm which runs inside that. It populates the file. It will ask you owner of the file, which we call it as UID, user ID. Supply it, you get your file back. That's how a file recovery happens on the Linux side.
Now you want to go to AI?
Yeah.
That's
One
the
more.
time.
Okay. This is one simple file that I want to do, but unfortunately time is running out. I can't do that.
Alrighty.
Okay. Okay.
When did you guys finish at 7?
Yeah. Yeah.
We should finish at 7.
Yeah, we have to finish it by 7. Okay. Okay. Maybe I'll run through these. This we have explained. Maybe the AI-based write technique I'll just explain. This is still on the protection, but this is more on your AI technique. You heard about supervised learning, right? And then, so now we're going to talk the supervised learning technique, which how exactly it is helpful in what we call protecting the data in 2 different data centers, right? So have you ever used a classification technique for any of the basic application building or sort of making a sort of a classification and reaching the bottom down your decision tree activations, right? Something like that. Now, in this example, on the storage segment, big storage vendors like Hewlett-Packard and NetApp, and they are using the AI models just to make sure how instantly or smartly they can sense there is some disaster is happening, I have to protect my data, right? As I'm just running through this example, okay, you can either ask me a question or think about your AI proposition, how you can inject it. I will be explaining it parallel, right? Let's say I got a cloud here and there are a set of users here, and they are all be, running through a different application, Java, Python, maybe ERP, banking solutions, could be anything, right? They're all coming through cloud. That could be a direct connections as well. When they come, usually they run through their softwares. Let's say on your FIU, you got your own dashboard, you log on to myfiu.edu, like that. Let's say you are the part of that, and the my.fiu.edu is an application service. It is taking the inputs, it comes to your FIU inside gateway, right? When it comes here, right, the application senses, where is that I have to go? Oh, I have to go inside. Here, one of the DNS server will tell, okay, you have to go to that storage. Now, when it comes to storage protocol, right on the storage, there will be a controller. There is something called smart is controller. That controller is built with your AI coded engine. That basically, I'm talking about a protection layer called RIDE, which we call it as redundant array of independent disk, which works on two different, there are plenty, but I will be talking only on one thing called striping, that is 0. A RIDE level called 0, which we call it as striping, right? So what exactly the AI model does here, if I say hello, feel that an application is trying to write a data called hello, okay? It comes here, the AI model senses, okay? Let's say, what is the value or what is the data packet that I have received? It's a packet called hello, right? It does your classification first, in the sense, is this a single unit byte or it's a complex unit byte? In the sense, does this packet is from a cloud application or this application is from one of the individual source? That's called single and complex. Once it is done, then it goes to the next ladder. Here, again, the reinforced learning model which is adapted to the system, what it does, do I have a packet already like this? It goes, checks into the storage disk, saying that yes, I already have. Should I rewrite? It thinks. It don't want to write, right? If it is a new packet, let us assume a new packet as a new packet. It says H, okay, H, I'm going to write onto the first disk. E, I'm going to write it to second disk. L, I'm going to write it to another disk. L to other. O to other. Means your A will classify the data, puts into two different disks. Why? Because your operations are quick, and whenever you want to retrieve, it is quicker. Why? Because you are reading 3 letters from here and 2 letters from here. The only disadvantage is in this system is like there is no fault tolerance. If you lose this, blah, I'm gone, right? But there's a new technique for that, right? We say mirror, write 1. In this case, your AI model, rather than splitting, it writes hello here and hello here. It might be redundant. You might be eating more data space or disk space, but your fault tolerant, highly fault tolerant, right? Even if you lose a disk, the disk will come back. Then another sophisticated CNN AI model, they have constructed RIDE 5. I'm sorry? Yeah. So what they do, they got 5 disks here. When the CNN model decides that, okay, I'm going to do a larger classification of data, it writes H here, E here, L here, and then H E L. What is the disk ID? 1, 2, 3, 4, 5. It says 1, 2, 3 P, and then one more L here, O here. So it keeps writing the parities in different disks. Let's say if I lose this disk, okay, the information that is recorded in this disk is also recorded in this disk. Okay, what I do when I insert a new disk, okay, my supervised learning method said I'm going to insert a new disk, take this new disk into the controller and rebuild the content. It says, oh, there is a new disk, I have to start from the beginning. It takes, okay, H belongs to this disk, E it belongs to this disk, and now I got L. It creates the disk content back in. It might take some time, but your recovery is going to happen. So that's how the rate, yeah.
What happens if disk 4 itself is lost?
This one. For that, very good question. Great. Okay. This content is written here. There is something called quorum disk. Okay, there will be an additional disk called quorum disk. Usually they all eat disk just to protect data, and this setup is again mirrored to another setup. That we call it as primary center, and this we call it as backup center, and one more we call it as disaster center. Your AI models will think, right, should I write it to primary or backup or disaster? It happens on log watch. Every now and then, frequently this keeps on happening. And anytime when you lose data, let's say this whole center is down, right, it picks up from here. Way back, I think Bin Laden has attacked your World Trade Center, right? Not even single bit of data is gone. And this writing of write, it happens in seconds.
And you hack those planes to damage the World Trade Center. Well, his people hacked those planes to damage the World Trade Center.
Yep.
Correct? Because they were using the planes were using a basic operating system while and the hackers knew how to hack it, right?
True.
And then boom, you have 9/11.
Yeah, but unfortunately they did not know. Osama bin Laden team did not know there is a AI. That time there was no AI, but protection was still there. Your data last 3 seconds when the crash happened, right? Except that your data is always safe, and that is for sure all the time, right? This is how it works. And next is something on, you heard about convolution layers. Have you heard about convolution layers, CNN layers in your deep learning things in AI?
Yes.
Okay. So using them, right, a new technology is created saying that you have a C drive and you have a folder. Can you create same name twice in a folder? Same file name in a folder? Usually what happens? It overwrites, right? Now, what's a new trend from AI? It should create. It should create, because I got my learning here, right? So what we do, from the deep learning technique, there is something called waffle, which we say write anywhere file layout. Earlier, what all the file systems that we talked? Extended 2, extended 3, FAT, FAT16, NTFS, HPFS, right? But if I use write anywhere file layout, what happens? When you create a file, your deep learning, first go to your file table, okay, read, there is a file called test.txt. What is the inode number? Some number, I don't know, right? Next time when I create, will it be same or different, the inode number? Different, right? That's a catch of your learning. Your AI model is a little more smarter. I say +1 pointer I to that. Now it creates a different inode number for this, but the label, though the label is test.txt, okay, there is a hidden character for that file, which is called control character, which as a user you cannot see, right? What happens? Otherwise, as I said, it is overwriting, right? Here there will be some control character, which you don't understand. But inode is different, control character is there, both the files are available. So that's your deep learning technique of file handling of waffle layout.
Is it similar to versioning?
I'm sorry.
Is it similar to versioning?
Fantastic. So have you done some versioning systems in the past? Good. That's good. And then comes your logical storage. That's another advantages of the array model. How many? Is there anybody in the hall who's got like 100 GB of space for your email, like from your Gmail or any public provider? Who has got 100 GB of email space? Nobody, right? Do you know how much they provide? 15? Cool. That means you've done a lot of workaround on your email boxes, right? 15 GB. Have you ever tried filling up 15 GB?
Yeah.
Sometimes. So what is that they say? It's over, so, right? This is for non-privileged users, like because you are a free account, right? In companies, like when you buy your iCloud, okay, you pay like $10 or $15, you buy a 50 GB iCloud space, okay? Again, the deep learning technique plays a smart way, right? Let's say there is a user called Lawrence here. He has got 50 GB. Another user called Yashas, okay, he has got 50 GB, okay. Let's say Lawrence is just very vague user, you don't use his storage much. The deep learning, what it does, the model is written to collect data sets. What are the data sets? Keep reading the file system. Keep reading the file system. I keep all the time reading my file system, and I apply weights. Weights of what? How many files that he create. I keep sensing how many files he create, and then I check the threshold. In a week, how many sets of files he create. Based on this prediction, I give away a report saying that, okay, looks like a person called Lawrence is not using that much. Okay. Now what I do next time, Yashas demands, because he's eating more disk space, he says I want 100 GB. You know what I do? It does not give you separate disk space physically. In storage, we just do a drama saying that based on my DNN report, okay, I just cut the space that is unused by Lawrence, the file system inode place, and give it to Yashas. That's all we do. We don't spend money on investing hard disks. And that's, you got a question. Go ahead.
What happens if that user now, you need more storage because he becomes more active? Like,
Okay.
what happens to that?
A very good question. Like, let's say after some time he also starts using. That's your point, right?
Right.
Now what I do, my model is still running, I go on other users. And obviously, on the earth, it is never possible that everybody will start using, right?
Right.
And you also know that every time when you put a URL, right, the URL earlier it used to end with a common single sign-on on globe. But now, if you browse any service, it comes with your country, right?
Yes.
DNS. So the learning model is so capable. If here it is night, there is day, I bring in data from there, or I use the space there. It's just a single pointer. Just like white IPs or public IPs, they're very quick. They get it. That's how it works.
So you have 10 minutes to complete.
Yeah, I'll just close it. Yeah, go ahead.
Yeah, the same applies to client storage, right?
Yeah, you're right.
Yeah, even to the processors, when you need more processing power.
Extremely. You need. That is the reason they have the 264-bit rack servers.
But
And
can they do the same thing where they can club in multiple processors and make it a big server?
Doable. Okay. I'm going to share this sort of script, probably. Okay. So let's get into the third module on your internet so that I can throw some lights using the AI and then the internet here. So what particular test is conducted on your network cards? Have you heard about Ethernet network, something like that? No? When you want to connect two computers, you basically need a physical card, right? Which connects two cables, right? So what test is used to test your speed? let's say if I want to run quick, right? I know how much my stamina is, my breathing stamina, how foot movements I can make. Just like that, every network has to be measured, right? So that God, maybe like since you guys are not exposed to that, I have to answer this. Yeah, the ping is a command that you use to reach that, right? And there's one command here, right? Ping 127.0.0.1. The other one is ping localhost. Do you see any, kind of activity, a deferred activity between these two? Which one is faster and which one is accurate? Just take a wild guess. Uh-huh. Which one is faster and which one is accurate?
Both are same.
Both the same?
Localhost is closer.
Oh, okay. Looks like I have to give all my black shift, right? Okay. Yes, they both are same. Basically, like when you want to connect two different computers, you got two different devices. But as an operating system, you talked about all OS layers, from physical layer to your all the application layer, in between lots of layers. For all these layers, there is an internal network testing. Okay, that happens on your loopback adapter, which is identified with 127.0.0.0. They both are same, nothing else. And be careful whenever you install a local XAMPP server to test your own applications. It locally runs on your box. It works like a web server, but since it is connected to internet and it has no IP address because your box does not have any IP addresses, if your XAMPP is not infiltrated or not infiltrated, like if you are not secure with your own Windows firewall, you are very close to get exposed. Be very careful on that, you might get attacked. I just quickly talk on this, then I'm gonna maybe wind up my sessions and end up a couple of AI talk. You have your cell phone. Everybody has your phone. You have got browsing, right? Everybody, all of you browse. When you say google.com, what exactly happens on your phone? How does it get?
Sends a request to the server, then the Kerberos.
No, the Google name get converted to the addresses.
Cool.
That's how it goes. Like first we'll try to find where the which network, and everything will go by address. So since if we find the user, we give a name like Google.com or Facebook, but that doesn't work like that. Always with the numbers, like 127 dot something like that.
Mm-hmm.
That's an IP address. That's how we get identified. That's how it works.
Good. That's interesting. Any other answers you guys have? Anyone wanna just?
Connection first.
Okay. So there are a couple of good answers actually, right? When you say any URL, okay, basically it goes to your domain name server, which we call it like what he said, right? He's right. So when you say google.com, the URL that you name is called DNS, domain name server system, right? Is identified by a physical IP address, right? It could be in any classes. You can just take this presentation and learn those things. What exactly the system does is when you supply that, right, initially it checks in your local cell phone. If you have already browsed your Google, it never goes there. It gives the page right away there. Only when you input something, then the response goes. Otherwise the response is always there. Let's say first time attempt of browsing something from your cell phone. What it does, it takes a repository. I think you might have registered with your Verizon or T-Mobile or some internet provider, right? So you go to your phone, somewhere in about us settings, there is an IP address associated to it. Your phone is always captured by an IP address. It takes that IP address. That IP address is controlled by your ISP, that is provider, Verizon. He verifies that he is an authenticated user to be or not. Yes. If it is so, then he takes that. He has got a BGP, which is called a Broadcasting Gateway Protocol. From there, he takes the request, throws it out. Where? That's called 13 root DNS servers. They are very much fixed on the earth since the day the internet from 1969 it started. I'm talking about these 13 root DNS servers here. We'll just run through there. These are the ones. Okay, these are the 13 root DNS servers on the earth. And these servers, you can ask the question now, right? These servers, they don't have a physical IP. Okay, they always run on dynamic IPs. One of the requests, let's say if I'm here in America, especially in Florida, I would see Okay, which is the closest one? The DNS server that I'm connected to. That DNS server will say, hey, you are close to me. I'll answer your question. It will take the request. And then, where is Google? Right? The request has to go to the Google server. It goes to the Google primary gateway. Right? From the primary gateway, it goes to Google's DNS server. From the Google DNS server, it goes to Google's google.com web page. Somebody might have created a page, right? It goes to the page. From the page, it records, writes all your source metadata, which IP, from where it has, everything is logged, and then the way it came, just like it comes back. You know how much time it takes? 1 by 10 seconds of GPs. Such quicker it happens. That's how your internet works. Now, AI-driven technique, especially on your called regression methods that currently that Google has implemented in order to reduce the, increase the speed and reduce the latency. Okay, anytime when you search from a particular area, it does a classification. Did he already searched? Yes. If you searched, when was the recent search? This was a search. What did he look for? Let's say I looked for something to search something like Angelina Jolie. Okay, he has already searched for a lady called Angelina Jolie. It does not even go to DB and get the data. Directly shoots. And there are plenty of binary BSTs. Binary search trees are placed. Those data structures will just pick that data, give it to the DLL. From the DLL, it returns to you very quickly that you can never ever imagine.
I have a question, like how does AI will differ from the cookies? Like we know, right, we use all browsers, so all the information are stored in cookies.
Yeah.
So that's how the pages are very fast. Like now you have searched one website, like say like google.com. So the Explorer has stored that website, giving that information. When I try to log in once again, it will fetch very fast. It doesn't go to the server actually.
True.
So how does this, now you call AI, right? So how does this AI will differ from that the current mechanism what we have it now in the
Gentlemen, your first name please?
Naveen.
Naveen.
Okay.
Amazing job. You're too good for this topic today. Like there are already a couple of browsers which you have heard about Chrome, right? Tensor, not right? Just go to Google, say the future operating systems. Chrome is already started an operating system which you never know. It's already part of life. We are all happy to use Chrome browsers, right? Just like the Naveen asked, you have stored multiple times. You have browsed hundreds of times, and there is a log watch for it. If you have browsed 100 times Google, there is only one last log watch will be remained. And what it does, from the browser cache, okay, from the browser cache, it does a classification, hits your ISP directly. Hits your ISP directly. That's your DNN. That's your deep neural network technique. It directly hits and then gets the data. So now Chrome and Google are tied up to do another an advanced method, saying that if you have searched for a particular pattern from the search, okay, rather hitting all these barriers, okay, just do a double linked list connection of a node to node connection. If it's a new pattern, send me there because he's already interested. And that's why Chrome is going to become more heavy on your operating systems sooner or later. I think I answered your question. Okay. Thank you.
Can you
Okay,
something quick about quantum internet?
I'll directly go there.
5 minutes.
I'm gonna, because sorry, I had too many. I wanted to talk a lot on hacking as well, but unfortunately it didn't happen. Okay, I'll directly jump onto the future internet and future security, where I think all the kids sitting here, like, we need your support writing the AI techniques on quantum. It's not quite easy. It's not like writing an array or a sort of a linked list or a Fibonacci series or something like that. Quantum is stuff like that. It only senses zeros and ones, or probably AND gate, NOR gate, CNOT gate. Completely electronics and completely you're back in those days, like 50, 60 zeros and ones. So what exactly a quantum is all about? You say like bit, 0, okay?
So in classical computing,
Mm-hmm.
so you have the binary, which is 0 and which is 0, 1, and the quantum, you're pretty much combining.
Yeah, true. So in binary digit, when you say a digit or a bit, either it is 0 or 1. But in quantum, you know, they are together. It could be both the states. Or when you measure, it could be one of the states. So now you can imagine what wonders a quantum qubit can do. So we call it as a qubit. Now saying that, how exactly quantum is more aggressive, it's still under, you know, what you call production. Not, to be honest, they are not available. Only QKD, quantum key distribution security protocols are available. You can go Hawaii, Toshiba, IBM, and then Google. They have got their own distributions. You can buy, use it for only security purposes. There are no basically quantum computers where you can just log in and do something. That's not the trend now, as of now, right? So how, you know, faster it is, right? It is something like that. Let's say I'm here, and one of my other friends, let's say, is in Switzerland, okay? And we both are in a measurement. Just feel this, right? This is just sort of a feeling. If I say computer networks topology, nobody has ever seen. Computer networks is basically always the illumination, just like that. I'm here, my friend is in Switzerland, and I say, we just do an entanglement. It's a physics process, right? And I say left here. If you call him and ask him, he would also say left. And if I say right here, he will also say right. That's a fantastic phenomenon of quantum entanglement. Now, how this entanglement is being used to internet? What they have done, okay, there is one quantum, okay, one single qubit processor here, and one maybe in the other lab, okay, and they are connected by a long fiber. Since as of now only 50 kilometers is the strength, beyond that it is not possible. What they do here, I want to send a qubit, I just use a photo emitting diode, because fibers can only transmit light, right? I send a light here. Let's say it's all the way it is going. Now let's say Yashas or let's say Lawrence wants to come in between, because that's how network, right? When two people are communicating, the other person wants to listen. That's a hobby of network, right? Yeah, so eavesdropper, basically, right? Now if you come in here, in general internet, yes, I can come in, I can read your packet. But in quantum, the moment when you come in, they both get alerted, because their entanglement is different. When somebody is coming in, the entanglement gets disturbed. So that's why quantum will be going in further in future, would be so super secure that it's quite difficult to break it. And there are already people who are also working on quantum hacking, and with the very good connection of Professor Iyengar and myself and one more researcher from Argentina. So we have already published a couple of very good papers which talks on under ocean and something like that. Maybe I'm going to end up here and then ask Professor Iyengar to come on the dais and then invite you people if somebody wants to do real quantum activity and internet activity. That would be really good. So saying this, I'm going to end up my presentation. Thank you, the AI Coding Club, Professor Iyengar, Jason Liu, and then all the faculty members for giving me an opportunity just to